Complete the following calculations with the correct number of significant figures in the final answer. And there's a hint here in the parentheses that we need to remember our algebraic order operations. As a quick reminder, that basically means that when you have complex calculations, you want to do the multiplications and divisions first, followed then by any additions and subtractions that might be present. In this first problem, we have only addition and subtraction. We have 120.00 plus 6.710 minus 4,750.0. So, on the calculator, if we type this calculation in and press enter, we get negative 4,623.29. However, we're looking for, in the addition and subtraction, we're looking for the one that has the fewest number of decimal places. So, the first number has 2 decimal places, 3 in the second, but only 1 in the last one. So our final answer needs to be rounded to 4,623.3, so that it also only has 1 decimal place in the final answer. In the second problem, we have 1,200 plus 340.2 minus 460. So in this, the 1 and the 2 are significant, which means that we only know the 1,200 to the nearest hundred. The 340.2, yeah, we know this to the nearest tenth of a decimal place, or tenth of a number. But the 460 we only know to the nearest 10. So we have one that we know to the nearest hundred, one that we know to the nearest hundredth, and one that we know to the nearest 10. So when we do our calculation here, 1,200 plus 340.2 minus 460, we can only know our final answer here to the nearest hundred as well. So that would round to 1,100. Our next one is all multiplication and division. So we can take our 260 times 3.14159 and divide it by 0.07. Now, when I press enter, I get a large number of digits. But for multiplication and division, we want to go off the fewest total significant figures wherever they might fall in the number. So our first number, the 2 and the 6 are both significant. So we have 2 sig figs there. For the next one, every digit of that, all 6 of them, would be significant. But on the last one, it's only the 7 that's significant. So in this particular case, we can take our 260 multiplied by 3.14159 and divided by 0.07. Oh, actually, I've already... No. I did that before, but with an addition, not a multiplication. So for this one, since the number that has the fewest significant figures in the original calculation only has 1, we need to round our final answer here to only 1 significant figure as well. So this would give me 10,000. Now last, we have a mixed set of calculations. We have some addition, subtraction, and we have some multiplication, division. We do the multiplication division first. So we take our 3.14159 and we divide it by 0.07. So with this, the 0.07 only has 1 sig fig. That's going to limit the answer for this portion of the calculation to 1 significant figure as well. So we would just have 40. If that had been 45, I would have rounded it up to 50. But since it's a little under 45, we round down. So now I have 260 plus 40. And since we know both of these to the nearest 10, my final answer should be 300. Now in this, I still know that 300 to plus or minus 10 in terms of rounding, to the nearest 10. We mentioned in class that this can be a little ambiguous. If you just saw 300, you wouldn't necessarily know whether it had 1, 2, or 3 significant figures, whether all those zeros or 1 or none of the zeros were significant. So if we wanted to be a little bit less ambiguous, we could convert this to scientific notation and write it as 3.0 times 10 to the 2. Now, unless a problem specifically asks for scientific notation as your answer, you can give it in either format. I'm okay with either way. But the 3.0 times 10 to the minus 2 is absolutely clear that that number was intended to have exactly 2 significant figures in it.